So here we're going to have a look at a dynamics question. This dynamics question is specifically on forces. So we are told a man pulls a shirt off a clothesline. He pulls with a horizontal magnitude of 50 newtons and a vertical magnitude of 120 newtons. So let's draw a picture. We have a shirt, which we'll just denote as a rectangle like so, is being pulled. It's being pulled this way. It's being pulled with a horizontal magnitude of 50 newtons. So the force this way is 50 newtons. And with a vertical magnitude of 120 newtons. So we're assuming horizontal is away from the clothesline towards the man and the vertical is down. We're asked to find the magnitude of the force. Well, based on our vector diagram, we can use Pythagoras' theorem. The resultant force, which we'll call VR, V resultant, squared is going to be equal to 120 squared plus 50 squared. So this tells us that VR will be the square root of the sum of those squares. So the square root of 120 squared plus 50 squared will give us 130. So therefore the resultant force, and this is actually just zeros, so therefore the resultant force, which I'm calling VR, this should be FR, change these all to FR, because these are forces, not velocities. So FR, FR, and we'll change this one as well. We'll call this FR. It doesn't actually matter what we call it, but we'll call it FR because that makes more sense. So force resultant is 130 newtons. So this is part A. Now the question also asks us to calculate the angle at which the force acts. So I'm actually going to do this as a bearing. Now I've written this question, and so I'm going to specify it as a bearing. If you are given particular parameters with which to find this angle in the question, you have to follow them. Because the teachers, if they want to be quite specific with how you have to do the questions, you have to follow their specific instructions, otherwise they'll take marks away from you. So let's have a look. Part B, calculate the angle at which the force acts. Okay, well we just drew our force diagram. It looked something like this. We said this was 130 newtons that way. This was 120 newtons this way. This was 50 newtons this way. So in order to find the bearing, we need to find this angle, and then we need to do 180 minus this angle. So the bearing will be 180 minus theta. Well, we can find theta using tan rule. So the sine, cos, or tan rule in this case actually. But we'll use tan rule. Tan of theta is equal to opposite over adjacent. This is 50 over 120. So this gives us theta is arctan of 50 over 120. And we can approximate this. So in our calculator, shift tan 50 over 120. This gives me 22.62. 22.62 degrees. This is to 2 decimal places. And so this implies that the bearing that we want is 180 minus 22.62 degrees. So therefore the bearing is 157.38 degrees. And this is to 2 decimal places. And this is the answer.